Hello students, I am Nilanjana Sanyal, an online math tutor from India. Welcome you all to my channel NS Online Math Classes. Now to tell you about today's topic, I have to admit that we do not have any new topic for our today's session. Then why am I making this video? Well, one of my students have asked me about a question on binomial theorem. She was facing some difficulty where both the variables were raised to some common power, and I realized that I did not make any video where I had included that type of a question. So I wanted to share that with you. That is one of my reasons for making this video, and there is a second reason as well, which I will be showing you or I'll be explaining when I take up that question. Okay, so stay tuned till the end and we start with our today's session. Okay, so the first question of this session says find the term. This is the first time that we are seeing this word, find the term. Every time we have seen they are asking for the coefficient, but in this case they are asking for the whole term, in which x and y are raised to the same power in the expansion of x square y minus 2y square raised to the power of 6. So let's start with our answer. So let me write the binomial expansion first. X square y minus 2y square whole raised to the power of 6. And as we have done always, we will be starting with the general term of this expansion. Since the power, that is the value of n, is 6, so it will be 6cr, and the first term, that is x square y, gets raised to the power of 6 minus r, and the second term, negative 2y square, gets raised to the power of r. Okay, and now what do? We have to find the value of r. That is our next target. So but before getting to the value of r, let me just write the general term expression in this format. I'm just separating the x and the y. So it is x square raised to the power of 6 minus r times y raised to the power of 6 minus r times negative 2 raised to the power of r times y square raised to the power of r. Okay, and now we can combine these two. Okay, so it is 6cr x to the power of 12 minus 2r. And y to the power of 6 minus r, and over here we are having y to the power of 2r. So it is y to the power of 6 minus r, and since these two are getting multiplied, so the powers will be getting added. So it is plus 2r, and of course there is the minus 2 raised to the power of r. Okay, and they are saying x and y are raised to the same power. That means this expression should be equal to this expression, because this is the power of x and this is the power of y. We have to equate these two expressions to get the value of r. So let us do that. 12 minus 2r is equal to 6 minus r plus 2r is 6 plus r. So it is 6 plus r. Or 3r is equal to 6, or r is equal to 6 over 3, which is equal to 2. We have found the value of r. Therefore, this is the entire term and we have to get the entire term. We will be just substituting the value of r in this expression. So it is 6c2 times x to the power of 12 minus 2 times 2 is 4. 12 minus 4 is 8. So x to the power of 8, y to the power of 6 plus r, that is 6 plus 2, which is equal to 8 as well. So you see x and y, they are getting raised to the same power, 8. And negative 2 raised to the power of 2. Negative 2 whole square will be 4. But what is this? Let us expand that part. So it is 6 factorial over 2 factorial times 6 minus 2, that is 4 factorial. And there is this 4. Let me write 4. Simple 4. Okay? And x to the power of 8 and y to the power of 8. And this is 6 factorial will be 6 times 5 times 4 factorial. We have done so many times, we have done this simplification of the factorials. So I am just writing this as 6 times 5 over 2 times 4 x to the power of 8 y to the power of 8. Okay, and these two can get cancelled. So it is 6 times 5 is 30, 30 times 2 is 60, or 5 times 2 is 10, 10 times 6 is 60. Anyway, it is 60. The coefficient is 60. Coefficient of what? Coefficient of x to the power of 8 times y to the power of 8 is 60. But we are asked to give the entire term, so we will be giving the entire term. So the answer is 60 x to the power of 8 and y to the power of 8. This is our answer for this question. Okay. So let us move on to the second question. Find the coefficient of x to the power of 9 in the expansion of x minus 1 raised to the power of 7 times x plus 1 raised to the power of 7. Now, we have done this type of questions before. In my previous videos, we have done them. I have explained the method to you. Then why did I take up this question? Actually, this is a special case. You see, the powers are the same. And for these two binomial expressions, the two terms are also the same, x and 1. The only thing that is different is the signs. The two terms are attached by the negative sign or the minus sign in the first expansion, and in the second expansion we have this plus sign. That is the only difference. So it is a special case. That is why I thought of taking up this question. Okay. So this is my second reason for making this video. And I have explained how to get to the coefficient, because they are asking for the coefficient of x to the power of 9 in this expansion. But today I'll be showing you another method which will be applicable only if you have the powers as the same number, and the two binomial expansions should be having the two terms, the same two terms, with the signs with opposite signs. Okay. It may be with same sign also, Okay, I'll be showing you what happens if it is the same sign. Okay, but let's start with our answer first. So this is a special case. You can proceed as usual in the as the general case, or else, since this is a special case, you can follow this technique as well. Okay, so, and for this I'll be using this law of indices, e raised to the power of m times b raised to the power of m is equal to a times b raised to the power of m. Okay, so I'll be using this law of indices. Therefore, x minus 1 raised to the power of 7 times x plus 1 raised to the power of 7, this is a, this can be thought of as a, and this is b, and m is equal to 7. So this can be written as x minus 1 times x plus 1 whole raised to the power of 7. And this is what? This is a minus b times a plus b, an algebraic identity, which is equal to a square minus b square. So this can be written as x square minus 1. And in case you are getting confused, you may go to the general technique. You may watch my video where I have shown you multiplication of two binomial expansions where one term is having the variable x. So you can watch my video, that previous video of mine, and you can use that same technique, that is the general technique, to get the coefficient of the term containing x to the power of 9. This is the special technique I am showing you. This is applicable only if you have this type of a situation. Okay. So now you see, previously we were having the two binomial expansions and these two were getting multiplied together, but now we are having a single binomial expansion. This is a single binomial expression which is getting raised to the power of 7. Okay. So we have just reduced the two binomial expansions to a single binomial expansion. Okay. And now we will be proceeding exactly in the same way that we usually proceed. That is, we will be taking up the general term expression. What will be the general term? N is equal to 7. So it will be 7 CR x square raised to the power of 7 minus r and negative 1 raised to the power of r. Okay, and they are saying that the power of x should be equal to 9. And from the general term expression, we are seeing that it is equal to 2 times 7 minus r, which is 14 minus 2r. So 2 times 7 minus r is equal to 9, or 14 minus 2r is equal to 9, or 2r is equal to 14 minus 9, which is equal to 5, giving us the r value as 5 over 2. And we know that the starting value of r is 0, and then the values go on increasing by steps of 1. Our starting value is 0 and all other values of r are positive integers. R cannot have a fractional value or a negative value. This is not possible. Okay. So therefore, we can conclude that there won't be any term containing x to the power of 9 in the expansion. Okay, because in order to get x to the power of 9, r should have a value of 5/2, which is absurd. Therefore, it suggests that there will not be any term containing x to the power of 9 in the binomial expansion. Okay, so what will be the answer? The answer will be 0 because there will not be any term. So what will be the coefficient of a non-existent term? Obviously it is equal to 0. So 0 is the answer for this question. Okay. So, and now that I had seen that what happens if you have the same sign, let me answer this part. If you had x plus 1 raised to the power of 7 and x plus 1 raised to the power of 7, then what happens? If I take this as a and this as a as well, a to the power of 7 times a to the power of 7 is equal to what? A to the power of 7 plus 7, that is 14. So this would have been equal to x plus 1 raised to the power of 14. Okay. So again you see the two binomial expansions are getting reduced to 1. But this is a special case, and in case you are confused, you may take the general case that I had explained in one of my previous videos. I'll be giving the link of that video of mine in the description area. Okay, so that you find it easy to go to that video and watch the video. Okay, but for this very question, the answer is equal to 0 because you will not be having any term which will be having the factor of x to the power of 9 in the binomial expansion. Okay. So students, this brings us to the end of this session. We meet again very soon. Thank you for watching this video till the end. Please like, share, subscribe and comment if you find this video helpful. So bye for now.